Thanks very much for joining. The purpose of this presentation today is just to talk through when anyone that's in the scaffold industry, whether you're a designer or a scaffolding contractor or anybody, I think we've all faced the challenges where the customer sends you a scope and there's next to no information. You don't really know what they want. It's just trying to find a way to navigate some of those challenges and get some outcomes. As you can see already, I'm not an expert presenter. I'm not a public speaker. I'm just a scaffolder who's, I guess I've owned and run scaffolding companies for, 20 plus years now. Makes me feel old. And again, look, I don't feel like I'm an expert. This is just speaking from my experience, and there's lots of different ways to do it. As everyone knows, if you want to build a scaffold, you ask 10 different people how to do it, they'll do it 10 different ways. So this is just speaking from my experience. So I'll jump in here. And like we said, if there's any questions, please feel free to ask any questions. All right, so the purpose of this is, like I said, just to talk through the challenges. We're going to go through a real life project that we've actually done ourselves, and hopefully you learn something from that. So just quick agenda. The plan is I'll try and keep it to 30 minutes or under. At the end, we'll leave some time for questions and answers. So if anyone's got any questions, please jump in at any time. A little bit of who we are. So I'm Simon. I've owned previous owner of Benchmark Scaffolding here in Australia. Recently sold that, exited that to be able to focus on ScaffPlan and the tools and the products and everything that we're doing. So been around for a little bit. In Benchmark, we kind of specialise in high risk and complex projects, mines, refineries, ports, bridges, reed repairs, blast and paint, all that sort of stuff. So had a bit of a finger in every industry, so to speak. And Ben Beaumont, he's the other director. He, similar story, owned a scaffolding design, temporary works consulting business in the UK called 48.3, recently exited that and joined our team. So we kind of got myself from the practical hands-on experience, Ben from the technical consulting business. So we're trying to cover all aspects of that. Cool. So jump into this project, right? This is the Queen Street Mall. So what you see right now is the scope that we got from the customer. They sent us this Google Earth link and said, oh, we've got to do some concrete facade works on this building. We need to get some scaffold. First question was, which bloody building are we talking about? I had no idea which was which. So this is the link that we got here. So it's a Google Earth. This is the main shopping mall for the Brisbane city. Again, which building? No idea. This is the link that they sent us. Turned out after we went back and had a conversation with them, it's this building here. We said, look, can you send through some drawings, some structural, some architecturals, anything that we got to be able to work with? They said the building, there's no designs, no drawings, nothing. We can give you some markups with a tape measure, but essentially all of the risk is with you guys to work out what's what. So I'll just zoom around in here. So you can see here, we've got a bit of a glass facade on the bottom. We've got public everywhere. There's these garden beds. They still needed to keep a lane of emergency vehicle access through there so that the vehicles could still come through, and still needed access into the buildings. Pretty cool, pretty typical job for a lot of scaffolding companies. I think it's nothing too out of the ordinary. Problem was this building was heritage listed, meaning we had to really limit what penetrations and connections and everything we put into the building. So everything needed to be approved by the council, by our contractor, by the building owner, and then all of the people that manage the mall. So a lot of different stakeholders in there that wanted to have a say. So pretty typical job, few challenges. So what we had to do is, because we had no measurements, no details, no anything. So what we did is we brought in a laser scanner. So a lot of people are familiar with these. They're becoming more and more popular in scaffolding now. So essentially what we did was set this scanner up in the middle of the shopping mall. This thing goes and shoots millions and millions of points, measures distances from the actual scanner to the building, to all the different surfaces. And then what it does is creates what's known as point cloud data. So you got millions of different points, laser accurate measurement on all the different points. So in this instance here, we used a Leica BLK 360. It's an entry level scanner. Look, I'm not here to sell you scanners. I've got no affiliation with these guys at all. This is just the scanner that we used in this instance. It's an entry level one, probably around about 45,000 New Zealand dollars to actually buy one, but you can also rent them. There's a global survey in New Zealand. I reached out to them yesterday just so I had some information to share with you guys. So you can actually rent these for about $600 a day. Great investment in my opinion. You never need to go back and take extra measurements so this is what it actually looks like after we've scanned it. So all of these little black dots are what the laser has measured against the surface. You can increase the density, the size, the color, all that sort of stuff. So if you want to go in and count how many leaves are on that tree, you can certainly do that. But what you do is you can see up here, we've got a big area there where we've got no data. And so what happens is the laser can only reach line of sight. So if the laser can't actually see something, it's not going to be able to pick that point up. So because we scan that from the ground, and you'll see a little bit further in the model, there's a lip that comes out off the top of this building here. So the lasers couldn't shoot past there to get that there. So what we do there is, I'll show you again in a sec how you can capture that. But then what you do is you move the scanner from place to place, and then it'll just, again, line of sight, be able to shoot different angles. Once we've got that point cloud data, we went through and actually remodeled the building surface. So again, you don't need to model the surface. You can build straight over the top of the point cloud. But as you see, if I go back to here, it's kind of messy. There's a lot of information on there, and all we really care about is this building here. So we want to get rid of the trees and get rid of these other buildings and everything, but we want to be able to turn it on and off so we can go back and take any measurements. So once we create that 3D model here, now that's accurate up to like that particular scanner. I think the accuracy is about 3 millimeters over 60 meters. So depending on which scanner you use is to how accurate they are and what distance they can shoot. And to be honest, you can go and buy scanners that are $100,000, $200,000. But for what we're doing in the scaffold space, I don't think it's really necessary, because you just might need to do more scans from more locations to be able to get that accuracy. And that's why I think that entry level scanner is a great option. It's, if you call it $50,000, but the time that you save and the extra money that you make by getting your designs accurate, I think it pays itself off in 12 months. So again, just my experience, my opinion. So you guys make your own assessment on there. So once we've created that 3D surface there, now we can see that there's that glass facade. We can see into all these window sills. We can see this is that lip that we were talking about before. So when we're scanning from down the bottom, obviously this laser couldn't get past that. So that's why that was missed. So from there though, we go and actually start creating the designs in the 3D environment. So here you can see an overlay with the point cloud data in there. We've got the model of the building in the background, all of the scaffolding, all of the point cloud, everything's all in one environment. So this project here has a whole heap of challenges. So when you come back to this point cloud scan here, we can see these garden beds, obviously the entrance into the shopping centres. So the client said, okay, this is the criteria. We still need to be able to get an ambulance past. So we needed to make sure that the distance between the garden beds and the scaffolding was enough to get an ambulance through. We needed to have openings for the shops. We couldn't restrict anything into the shops. We couldn't touch that glass awning under any circumstances. It couldn't be removed. It couldn't be touched. It couldn't be replaced. There's also, and I'll show you this, I'll show you this in another slide. There's actually disabled, they're called tactile indicators that run through the mall. So people that have maybe vision impaired, they've got the little dots on the ground so they know where to, we couldn't obstruct those either. So it's a pretty complex restrictions, although the job itself was quite easy. It was just all of the restrictions from the other stakeholders. So what I'll do is now I'll just open up 3D model here. Cool. So here we've created the scaffolding over the building, and I wanted to show this example here because this is a clean example. Once all the point cloud data and everything's been removed, this is essentially all we really need to work with. Because we've captured that scan data, we can actually turn that on and off as needed. But for the purposes of this, the point cloud data was not needed, so we could scan around that. So coming into here, you can see we can scan in. We've put in some elevations here. There's some entrances in and out of the shopping centres. They wanted to be able to see the emergency vehicle access, and so having all of those things in one place was really, really critical to be able to see. So Any questions on that so far? Is that making sense? No questions? That's normally a good thing. So with this building facade down the bottom here and this glass awning, this was the real critical piece that we had to try to overcome. So what we needed to do was cut little wedges into the windowsills here so that we could crane the beams into position. So it was really, really critical that we knew exactly where those little cutouts in the windowsills needed to be before we started doing the scaffold installation. Because if we build this scaffolding on the ground here, and then these bays are in the wrong position, when we crane the beams in, the beams aren't going to line up with the little recesses in the windowsills. So this is where it gets really tricky. If the ideal world is the client gives you a perfect 3D model, but I don't know about you guys. In my experience, the clients very rarely even have those models. So it's really, really difficult to get that information. So without using that laser scan data and being able to work on those point clouds, we can millimeter perfectly understand where those recesses needed to be. So each one of those were cut into the windowsill, the beams were craned in, Cam set it into there to be able to support those inboard loads. And again, these standards on the outside here needed to line up perfectly with those beams to be able to land on those windowsills. So if going back to the original Google Earth image that they sent us, man, I don't know how we would have done that without the laser scan data. We possibly could have gone with tape measures and measured it and could have possibly got it right, but it's really, really difficult without having that point cloud data. Any questions on that? Is that making sense so far?
We've just had a comment coming through from Alex saying, correct in the IFCs or OBJ, given even have issues.
Yeah, 100%. It was a good example is we did another project recently where the client gave us a 3D model. So we went in and started building the scaffolding around the 3D model, and then we turned out that the model was actually not correct. It hadn't been scaled properly, so nothing fit. We went back in and said, look, the only way to fix this is to laser scan it again. We went in there in the space of 2 hours, we had a scan data. We overlaid the IFC straight over the top of the point cloud data, and it was purely that when they'd done the model, it was out of scale. So it's just a really accurate way to get it right. And, you know, in that instance there, think about that project, we had 10 scaffolders on the job. We had stand down for 2 days to while we worked out what was the issue with the design. So that $50,000 that you spend on that scanner, all of a sudden you've paid most of that off in that one job just by saving the downtime with the scaffolders standing around on site. So look, in my opinion, it's a no-brainer for any scaffold company that does detailed designs, not even scaffold companies. We've got quite a few customers now that are just design companies that just do designs for other people. And they've now integrated laser scanning as part of their service for their customers and, you know, getting some really cool results. So that's a really important piece. So I'll just cut a section here just to show some of the complexities in this beam arrangement. So you can see here some of the layout with the beams, being able to get all of the different bracing in as per the engineer's specs, getting all of these recesses in the window sills correctly aligned. So the design piece itself had a few challenges. The upper limits look reasonably straightforward. It is a facade at the end of the day, but then getting into all of the different window sills was a little bit complex as well, because we had to cantilever in, and if we'd just drawn this in 2D and we're looking just from a side elevation, it's really difficult to see all of those little cantilevers in and around the window sills. So look, 2D still does have its place. A lot of quite basic projects, 2D is quick and easy. But if you want to get accurate takeoffs, accurate designs, in my opinion, 3D is a no-brainer. So like I was saying, the design itself is reasonably straightforward. But then remembering that we're in a shopping mall, all of this work needed to be done at night shift. The vehicles needed to come in at 10 p.m. in the nighttime. We needed to be gone by 5 p.m. in the morning. So we needed to be able to stage all of our materials. So everything that came in at the start of the shift had to go out at the end of the shift because the shopping mall needed to stay open. So really, really important to get that design and that model accurate, so that as we bring in those materials at the beginning of the shift, we know that we've got the materials we need. We don't run short on anything. Really, really important that aspect. Again, being able to provide access up. We did end up putting ply hoarding on the bottom of these, call them buttresses, rostrums, lots of different names, propping towers, shoring platforms, whatever you want to call them, to be able to prevent public access. But essentially, that was the major challenges. So you can see here again the building. This is why we drew the car in there, just to be able to make sure the clearances. Another challenge which came up was we were working for our client, right? That client is working for the building owner. In that building is owned by the people that own the shopping mall. That shopping mall is governed by the people in the council. So there's all these different people that wanted to be able to see what was what, be able to communicate, be able to collaborate. The shop managers needed to be able to make sure that their shop windows weren't obstructed. So many different pieces that needed to go into it. And that's why working in the 3D space was so important, to be able to communicate and share with everybody what was what. And it got down to the point where even the council engaged building certifiers to come in and then do certification on the tactile indicators for the vision impaired. So many different pieces that needed to be collaborated. And once we started building the scaffolding up through the point cloud data, we discovered that a lot of the scaffolding was actually hitting some of the branches of the trees. So then we needed to go back to the environmental consultants and say, hey, we need to get some of these tree branches cut. There's just so many different pieces to it, which makes quite a simple job really complex. And as you guys would know better than anyone, when you're communicating with 10 different people, everyone's got a different opinion, and sometimes egos get in the way and they all try to put their own spin on it. So being able to just create it in the 3D space and then just share that with everybody, and then have everybody collaborating and communicating in the one space was really, really critical. And this is a good example here. This is a different project with laser scan data as well, but the ability to be able to look at the overlay of the point cloud data over the top of the scaffolding to then be able to identify any clashes, any obstructions. And this here is just a great example where you can see the clash. You can see how much of a clash it is and go through there. So really, really important pieces. Here's a great example too. If you don't want to go to the level of using point cloud data, and again, I'd highly recommend that to anybody in the industry. It's a no-brainer in my space. You can go in and just draw the building yourself without it. You just got to be really, really detailed in making sure that your all your sizes are right, all your dimensions are right, everything's accurate and on point. So you don't have to use point cloud data. That's the point that I was trying to get to. But if you do, you're just guaranteed that your accuracy is on point. And I'll just skip back into here, and you can see some of the level of detail there. It's also really, really important for the scaffolders. And again, I've been on the tools for, I don't know, longer than I wish to remember. And when I first started, we'd get a set of scaffold plans, we'd throw it in the bin because we thought we just knew better than what the designers do. But that's evolved a lot over the time. And here you can see the level of detail that and the thought that goes into it. You know, the scaffolders necessarily aren't involved in all of the conversations with all of the different stakeholders. So if it's a really good opportunity to sit down and communicate with everybody before the start of the project, so they can understand the reason we did this is because of this or X or Y, and just be able to communicate all of those restrictions, because otherwise scaffolders know best. They'll just do what they think is best and say, oh, whoever did the design just doesn't know what they're doing. So it's a really, really great opportunity to, I guess, get everyone aligned and understand the full scope and the complexity of the job before they start. Also, with being able to crane all those beams and everything in, there's some quite critical lifts there and making sure all the alignments and everything's correct. So you can actually eliminate a lot of the risks in the project purely through the collaboration before the job starts. So look, and as designers and scaffold managers or supervisors or whoever's running the job, we've got an obligation to make sure that we design out as many risks as possible before the job starts. And this is just a great example of that. So this is where I touched on here, being able to share the information with all the different stakeholders. If this is done in 2D, traditionally what would happen, guys would print out a piece of paper, they'd get their red pen, they'd put all their comments on there, and then whoever the designer is would be stuck trying to navigate through all of the different comments. And quite often you get different people making the same comments, but just slightly different. Whereas if you design it in a 3D space and it's a collaborative environment, everybody can communicate on the same model. So here's a QR code. If you guys want to scan this QR code right now, it should open up on your phone, which is really, really important. So when the guys on site actually start the works, they've also got, you can give them a PDF drawing, but most of the guys these days now, look, let's be honest, scaffolders spend their lunch breaks, most of their time at work, even though they shouldn't, on Facebook or Instagram or TikTok or God knows whatever else there is. So it's never going to change. It's going to get worse as we go. So if we can kind of harness technology and get the guys using their phones to be able to accurately communicate, be able to zoom in, click on items, be able to see what something is in the drawing. If there's a detail that they don't quite understand, they can zoom in on their phone and be able to see what it is. If they've got any questions, you can also create tasks in there, send a live note back to the person who did the design to say, hey, we can't do this for, there might be a rubbish bin or a hole or a trench or something in the way. The scaffolders then can communicate that back live to the people in the office. They can update to the design, send it back, have a solution there, and go from there. So it's just a really, really powerful way. And again, the purpose of this presentation was not to try to force you to use laser scanners or try to force you to use 3D or collaborative spaces. This is just the experience that I've had on different sites and ways that we've tried to overcome different challenges and yeah, I guess solve problems before they become problems. And I think that's the mindset that anybody who's designing or managing a scaffold team is, if we can be of the mindset that we can design out as much risk as possible, then the project's got a lot better rate of success, because there's huge labour shortages around the world. New Zealand's no different to Australia or the US or the UK or anywhere. And years gone by, you just send a truckload of materials, send the guys there and they'd work it out. But the problem we have is all of those really skilled scaffolders are now leaving the industry, and we're left with a lot of young guys that are still coming through. And a lot of that knowledge hasn't been passed down from generation to generation. So I think holistically overall, the skill level of our scaffolders today are not as high as what they were 5 years ago, and even less than what they were 10 years ago. So by being able to design in the 3D space, get our designs 100% accurate, be able to communicate with the guys before they turn up on the site, be able to eliminate the risks and try to communicate with the guys so when they turn up, they know exactly what piece goes where. And if they don't, we've got a tool for them to be able to ask questions back to somebody that's done the design. So I think that's a way that we can really harness technology to overcome not only labour challenges, but also skills, material shortages, et cetera, et cetera. So I think that's, in my experience, that's what I believe is a possible solution. So yeah, I guess that wraps up my part. If anyone's got any questions or any information, by all means, ask a question now, reach out, send me an email, a message, a text message, send a pigeon with a piece of paper, however you want to get in touch, reach out. I just see here, Claude sent a message in. I try to get at least the CAD files or better on my most recent projects. I'm getting IFC models. Great. And the good thing is, if the customer can send you an IFC model, then essentially you're putting the risk back onto them. If that model's not correct, or it hasn't been interpreted correctly, or for whatever reason, you can say, hey, you gave me this model. I did the best I could with what you gave me. But in a lot of instances, if it's a new construction, there's always a reference model somewhere. It's just a matter of asking the right person to get it. And where the laser scanning is really, really powerful is in industrial plants where there's piping, ducting, structural steel. There's just so many different things everywhere. It's really hard to get an accurate model. And if there is an IFC or there is a model created somewhere, generally there's been maintenance done, or there's been extra piping added, or something's changed that hasn't been updated in the drawings. So if you just create that 3D model off those drawings, chances are it's not going to be accurate. So to go into an industrial plant or an existing bridge or something like that, it literally takes, by the time you set up the tripod and do maybe 5 scans, it's probably 20 minutes. It's super easy. If you can operate an iPhone, you can operate a laser scanner, point, press start, that's it. It automatically meshes all of the different pieces together, so you don't have to actually do it yourself. But then you know that model is millimeter accurate. There's no guessing. So, but now, good question or good comment, Claude. Thanks for sharing that.
We did have a question come through from Shilpa asking, how do you pull out quants from architectural drawings and no structural drawings?
If you get a set of architectural drawings, look, you can go through and take quantity sizes off there by working out square meters, face meters, cubic meters. Depends on what information you actually want to get out of that. In my opinion, if you've got a set of architecturals, first bet would be to go back to your client or your client's client and ask for a 3D model, depending on how old the building is. Anything sort of post year 2000 onwards, there'll always be a 3D model. Everything's designed in 3D. If it's an older building, perhaps not. But even by having the architecturals, you can still bring them into any design program. You can then recreate those building, and you don't necessarily need to go and add in all of the windows, all of the slabs, all of the doors. For a scaffolder, all we care about is the walls, the roof, ground. So quickly bring in an architectural, draw the walls. Most of the time, you don't even need to draw the roof. Again, and if the ground's reasonably flat, don't even draw the ground. It's just going to be the height of the base jacks that it gets adjusted. But if you want to go to that level, you can definitely do that. You can pull all the quantities and everything from that once you've recreated it. But the biggest thing is, if you don't ask for a model, you're not going to get one. So it's just a matter of asking your client, educating them on why you need it, talk to them about the accuracy that you can get, you can save time. And especially if it's pre-tender, if you can get that model, you can 100% accurately, I shouldn't say 100%, 99% accurately estimate your materials, your labour, everything that you need to do that job. And that's just a matter of communicating that back to your customer. So they might have to send 2 or 3 emails to find that model. But if you can help them understand that your price is going to be so accurate because you've got that model, then they might actually do it. Otherwise, they just go, not my problem, work it out yourself. So yeah, that'd be my advice.
Brilliant, excellent answer. So we've just had a question come through from Anthony saying, how much engineering input was there upfront on the Queen Street project?
There was absolutely zero engineering input upfront. So we had to go through and the first part was to do that laser scan data and to be able to understand the angles of those window sills and everything. We needed to be able to work out, firstly, where we needed the beams to land to fit in with the scaffold bays, but then secondly, what's underneath those window sills. So we had to go back through, I don't know, 80, 90-year-old drawings to try to find some structural details. Story was we couldn't get to it. So what we had to do was build a temporary platform to go up there, had to break away some of the windowsill to actually see what was under there. Once we were under there, then we could work out that there was some back-to-back PFCs encased in concrete there. But again, we didn't know the depth, we didn't know the width, we didn't know the size until we get in there. Same thing with it's a pavement in that mall. So we didn't know what sort of, what was underneath that pavement. Was there underground sewage pits, electrical pits? We didn't know that. So we had to bring in a dial before you dig style guys to come through and scan that concrete to work out what was under there. Had to do some DCP testing to work out what the compaction levels were underneath. So it was all, again, the client sent us a Google Earth link and said, hey, can you put some scaffold up there for us? We're like, sure, we'll work it out. So.
Oh, fantastic. We had a question as well come in earlier just asking what kind of software that you use for creating 3D scaffold design and model. And I guess, is it all in one that you use or do you use multiple?
So the images that we showed through today, that's in ScaffPlan. So that's obviously, this is the software. Like I said, originally I owned Benchmark Scaffolding. We first built what is now known as ScaffPlan just for us to use internally for our own designs. we tried all of the different other softwares on the market, and that some of them were good in some aspects and some not so good. So we built a whole range of tools just for us to use internally. And then it kind of evolved and people saw the tools and what we were using. And then, so they wanted to use the same tools. And at the start, we were like, piss off, these are ours, we're not sharing them. But it kind of evolved into an entire separate business. So now, like I said, I've exited Benchmark, solely focusing on ScaffPlan. And so we create the software and build all the tools and everything for everybody else to do the designs. So if people want to license ScaffPlan to do their designs, and I know there's a few people in this meeting that are already using the software, getting great results. So if you're interested, reach out, let us know. It wasn't really a sales pitch, it was more just an education piece. If you don't use ScaffPlan, use whatever it is. I don't care what solution you use, but the purpose of this was to identify the advantages of using laser scan data to just get that accuracy. But look, by all means, if you want to have a chat about ScaffPlan, give us a call, reach out, we can talk through more.
And then we just had Claude adding in there again. In one of my most recent projects, I used the client's IFC model, and then we had a Scaffold build next door, and the client also had the point cloud model.
Great outcome. And so what I used to find was that when you talk to the customer and you say, hey, we're going to come in and we're going to laser scan this, the first reaction is normally, what the hell is laser scan? And then you talk to them through all the same things that I've just said to you, and they're like, well, can we get a copy of that? And we're like, yeah, no dramas, but it's quite expensive. We normally do it just for us, for our own accuracy, even though it's not that expensive. You make the customer feel like it is. And then probably 80% of the time, you can actually convince your client to pay for that point cloud data. You can say, well, look, I can do it. I need to charge you $1,000, $2,000, whatever it is, to cover the cost of the point cloud, but then you will own it. So essentially you get an extra revenue, they're paying for your time to do the point cloud data, you get the accuracy, you get the efficiencies, you make more money on the job, but they're paying for it. So win-win.
Excellent. And we've got another question here. What kind of measures would you consider to minimize tie points when it especially comes to heritage building projects like the one you took an example of today?
Look, this is a huge challenge. When you got a heritage listing building, their goal is always zero ties, zero penetration, zero everything. They want it to be completely freestanding, not touching anything. Reality is, in a job like this, is borderline impossible. So what we did in a lot of these here, we had to actually, we gave them a combination of options between actually running a scaffold tube with a base jack top and bottom and propping it into the windowsill so it doesn't actually penetrate, but it acts as like a tom tie, thrust ties, some people call them. So the idea was to put as many of those in as possible to limit the amount of actual drilled in anchors. Because Brisbane is in a high wind cyclonic area, we did some wind analysis to work out what the recommended wind speeds were, and it turned out that we did need to use some actual drill-in anchors. The tom ties were good, but didn't solve the entire problem, because if a storm is coming and you get 1 hour, 2 hour, 3 hours notice, you don't have enough time to get to site, pull all of the planks out, pull any mesh or anything off. So you need to be able to make it to be able to withstand those wind pressures. So they said, okay, well, if you need to anchor, tell us where they're going to be, what type of anchor, what are you going to be drilling into? And if we didn't have that point cloud data and that model 100% accurate, and then that scaffold modeled over the top of it, it would have been impossible to say this exact coordinate is where that tie is going to be. We're going to penetrate 75 millimeter with a 12 mil anchor. We're going to go in 110 mil embedment, for example. Without that data, it would have been impossible to tell them. We just would have had to draw a big box and say it'll be somewhere there. But another way to limit the amount of ties, and this is something that's come quite popular only in the last maybe 2 or 3 years, especially through Europe, is they actually run like aluminium lattice beams vertically on the outside of the scaffold and connect them to the scaffold standards. So that makes those scaffold joints a lot more rigid because you've got another beam essentially running in parallel. Doesn't eliminate the need for ties, but you can space. If you were going to go 2 meters or 4 meter centers, you might be able to get it to 6 or 8 meter centers. But that's something that's quite new, but it's gaining a lot of traction.
Brilliant. I think that's a really great comment as well on the consideration of weather. Weather is something where you can consider the scaffold's going to be safe if it's perfect weather, and that might be when you're erecting it, but definitely considering, okay, what happens if it's going to be a storm? That's a really big consideration and a really great point.
Yeah. Like I said too, so if anyone's got any questions, normally once you leave these things, you think, oh, I wonder what should have asked this or should have asked that. Just send me an email, send me a message. What's your experience with demolition jobs, facade, scaffold, retention? Could be two answers there, Claude. Demolition being that they're demolishing the entire building, including the facade, or it could be that you're keeping the facade in place, retaining the facade, and then demolishing the rest of the building. In both instances, probably two different approaches. Demolition is, how do I put it politically correctly, bit of a nightmare, because you've got to be able to build the scaffolding all the way to the top. In having, you don't want to have too many, it's kind of counterintuitive. You need to have lots of ties because as they're demoing the scaffold, you don't want the scaffold to fall over. But at the same time too, if you have too many ties and the demo in the building, you don't, and then they break out a bigger piece of the building than what was expected, and you've got a tie in that section, it causes issues again. So it's a bit of a combination of having too many ties or not enough, and it depends on the demolition process. If they're just coming in with an excavator and just scraping it away, that's probably more of a challenge. Whereas if they're cutting it into sections and removing it manually, that's a lot easier to control. The engineer overkills on ties, mate. The engineer overkills on everything: braces, ties, sole boards, you name it. But that's their job at the end of the day. They've got a personal liability to make sure that that scaffold doesn't fall over. Look, it is what it is. And that's the challenge with whoever's designing the scaffolding, whether it's a designer, an engineer, or a scaffold manager, having an open and honest communication path with that engineer. And this is one of the really cool parts of being able to share live models and communicate, is if they say, oh, we need extra braces here, you can challenge it. Why do we need them? Can't we do this or can't we do that? It's a lot easier to communicate in a live model rather than the good old red pen and paper.
Excellent. And we haven't had any other questions come through just yet. We did have one question or comment perhaps come through earlier when someone was registering. I'm guessing you know them, Mark from Scaffold Studio. He just asked, are you human, Simon? Cheeky little emojis.
I'm as human as they come. Like I said,
I'm guessing your experience there makes you a bit out of this world.
Not a presenter. I'm not polished. I've just been there and done some things. I've made lots of mistakes, make more mistakes all the time. I can see Ilya's in the group here. He works with us at ScaffPlan. He gets to see all of my mistakes on a daily basis. So certainly human. But Mark's a customer. So interesting story with Mark is, I wonder if that's maybe tactical why he asked that question. So he's a design consultant based in Australia, and I hope I'm not speaking out of school here. So he's a ScaffPlan user, uses the software, and then he actually went and bought laser scanners to help for his customers. So on tricky scaffold designs, he'd go out and scan it and then do all the modelling and everything. But then he saw an opening in the market. Now he actually provides laser scanning services to other companies as well. He does, like, people that want to put a pool in their backyard. He'll go and scan their backyard so then they can put the pool in and get a, real life measurements. Does internal buildings for real estates and all that sort of stuff. So funny story, how it started from scaffold design and kind of evolved into a separate business.
Excellent. Looks like Anthony's just asked another one there. Once all of the design parameters were identified, what was the approximate time frame to model the first draft of the scaffold?
Depends which we consider the first draft. This design changed quite a few times. The original scope was just like where I showed those beams that were spanning across the top of the glass. The first version was only that level and the first level of scaffolding on top, because they wanted to break out some of that concrete to actually test the structural capacity of it before they did other concrete works. So that was stage one, to be able to get up there and do survey, I guess we'd call it. They needed to be able to break away some concrete to see what sort of MPA of concrete they've got, how much, when they break out one square meter is bigger than that, but 1 square meter of concrete, you know, what percentage of that 1 square meter has got concrete damage, to be able to to be able to forecast the scope of work for the rest of the building. So that was level 1, stage 1. They did that, then built a bit of a scope of works, went back to the building owner to get funding to do the entire building, and went from there. So look, to model the building over the top of the point cloud data depends on what sort of level you want to go into. You know, like this entire building, to go and recreate it from scratch now, the entire from beginning to end might take 6 hours, 8 hours, depending on how fast you are. But the majority of the time is actually thinking, how am I going to put that beam in? How am I going to join it with couplers and tubes and bits and pieces? So it depends on the skill level of, you know, the bulk of the time is actually thinking how you want it to work. Once you know how you want it to work, actually drawing it takes no time at all.
Excellent. Thank you everyone for joining us today and taking the time out of your busy days to be here. Thank you again, Simon, for presenting and taking time out of your busy day to be here as well and share your expertise. So we hope you've all enjoyed learning more about some of the solutions to some of those tricky problems and where clients haven't given you a lot of information. So from Sans, ka kite anō.